So now let's move on to a couple of card problems. In this first one, we're going to say what is the probability of being dealt 3 kings and 2 jacks in a 5-card hand. So this is a type of full house where I've got 3 kings and 2 jacks. Remember, full house are 3 of a kind and 2 of a kind, but I'm going to tell you specifically what the kinds are here. We're going to find the probability of 3 kings, 2 jacks. So we have to figure out the number of ways to get 3 kings and 2 jacks and divide that by the number of ways to deal 5 cards. Order doesn't make a bit of difference when you're dealing cards here. On the bottom, I'm going to say the way to deal 5 cards from 52 is the combination of 52 cards, choose 5 of those. Now on top, we know what the denominations here, so the only thing that we really have to decide is from the 4 kings, which 3 do we want? Order doesn't make a difference, so we're going to do combination of 4, choose 3. Now we need to figure out which of the jacks we want, and there are 4 jacks to choose from. I want 2, so that's going to be combination of 4, choose 2. With those numbers in mind, now I need to go ahead and work out all those combinations. 4 choose 3 is 4. 4 choose 2 is 6. And the combination of 52 choose 5, all the 5-card hands, is 2,598,960. When I divide that out, I get 0.00003848. The probability of getting dealt specifically 3 kings and 2 jacks is not very likely. And you're probably thinking, wow, I've gotten a lot more full houses than that when I'm playing cards. But what you're thinking is a full house. This is a specific type of full house. If you're thinking, what is the probability of being dealt a full house in a 5-card hand? Well, now we're going to have to do the same thing we did before, but we're also going to have to figure out the denominations of each of the 3 of a kind and the 2 of a kind. To find the probability of a full house, we're going to have to figure out the number of full houses there are and then divide by the number of ways to deal 5 cards from 52. So again, that denominator is not going to change. It's just going to be C of 52, 5. Compared to what we just did, you see the C of 4, 3. You see the C of 4, 2. So from the 4 cards in that denomination, we want 3, so we get our 3 of a kind. From the 4 cards for the other denomination, we want 2. But now you have the 13 and the 12. Because for this full house, we don't know what the denomination is. From the 13 denominations, we need to choose one of those. And there are 13 ways to do that. Once we have that first denomination, we'll choose 3 cards from it. From the remaining 12 denominations, so once we've picked our 3 of a kind, there's only 12 more to choose from. So we get from the remaining 12, now we need to go ahead and select 2 cards within that denomination. To do a full house, instead of the 2 choices we had before, now we have 4 choices. You have to choose the first denomination and the second denomination, so that's the 13 and the 12, and then you have to go ahead and choose the 3 of a kind from the 4 cards in one denomination, the 2 of a kind from the 4 cards in the other denomination, and then of course you need to divide that by the C of 52, 5. So if I work out all those numbers, I get 13 times 4 times 12 times 6 divided by the 2,598,960, and when I work that out, I get 0.00144. That would be a 0.144% of getting a full house. So full houses aren't real. You don't get a lot of those. It's less than or a 1% chance.